Okay, we're looking at question 14 from the 2024 tech-free paper for maths methods. So here we're given some information about some data collected at a football game. We know that 60% of spectators support the home team, and then they've taken groups of 10 and got the data from there, where they've got A for they support the away team and H if they support the home team. They want to graph that, and they've done the first one for you, which is always good if you're not sure exactly what they're wanting you to do. So see how we've got the 0.8 there, 1, 2, 3, 4, 5, 6, 7, 8. That's where they're getting that from, 8 divided by 10. For group 2, we've got, and I'm just going to put the answers at the end just because I know there is a double up. So I've got my 0.8 there. Then here I've got 1, 2, only 2 there, so that's 0.2. Here I've got 1, 2, 3, 4, 5, so that will be 0.5. Group 4, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, so that will be 0.9. Then I've got 1, 2, 3, 4, 5, 0.5, 1, 2 there is 0.2. So I now need to graph that. So I've only got one of the 0.8, so that's there. I've got 2 of them at 0.2, so I need to take my ruler and go up to 0.2 there. And then I've got 2 of the 0.5s, so I'm going to put 2 here. And then I have 1 of the 0.9, so that's going to come over here and draw that there. So that was worth 3 marks. That's a fairly easy 3-mark type question. Then on the next page is an interesting one where it's related to this one. It's part B of this question, and we've got if the researcher had interviewed more groups, each containing 100 spectators, describe 2 ways the distribution of the resulting sample proportions would be expected to differ from what was shown in that previous question. So they only took 6 groups, only 10 in a group. So if we've got more groups, we know that it is going to more look more like the 60%. So we would have a more, and if you look at the marking scheme, they talk about it being symmetrical around the 0.6. So we're going to have it more around that 0.6 mark. And more samples, more spectators is also going to mean that our variation is going to be smaller. So if we were talking in terms of standard deviation, it's got a smaller standard deviation. And so when we look at a graph that has a large standard deviation compared to a small standard deviation, we can see that it has a taller peak or a narrower. So we might talk about it being a narrower distribution. And they're the 2 things that they are looking for in that answer. A, that it's going to be more around the 0.6, and B, that it's going to be narrower because you're looking at more people in the sample, more samples, it's going to become closer. And you might think about that in terms of your margin of error type questions where the bigger the sample, the smaller that margin of error becomes. So you may relate it to that.